Good evening, sir.
Good evening. Good evening. Good to see all of you here. So, welcome to the online live online problem solving session. So, let's wait 1 or 2 minutes for others to join. Then we will start. Maybe before we can just get a feedback on how all of you are finding the course. And any suggestions or room for incorporate in the next sessions or something like that.
So I'm PhD scholar in NIT, actually in the architecture background. So initially, like I had a little bit difficulty in solving problems and all. Like now things are getting into track. In initial, I think the second video and all we had a little bit problem, and sometimes like we are just missing a few things, and instead of that, it is getting better. Like in probably able to understand much better.
Good.
Yeah.
The video quality is okay, right?
Video quality, everything, explanation, everything is fine. The only thing we are in from a different background.
Yeah, understood. Understood.
So suddenly the mechanical mathematics comes, like it is a little bit problem for us initially. Like we are getting into adjusted with it, and then because after 2 weeks, I think you are explaining the problems in the class itself. So so then we are able to answer the assignment. So if it is very complicated problem, like we won't be able to answer it. That's
no, yeah, I try to keep the problems as simple as possible because the background is diverse here, and I'm trying to do as many tutorial problems as possible to help you in that regard.
Yeah, it is helpful, sir. And last week, the assignment, the 5th week assignment, and made a mistake in that how many times the solar radiation is falling. Like we got it as 4 times, and its answer is 16. So maybe if you can explain that, it will be.
Sure, I can explain that. Let me check. Which week's assignment is that?
Last week, 5th week. 5th week.
5th week. Okay, 5th week assignment. Let me just check once minute. Okay.
I think you can explain it after all the students have joined. And one more question from my side is true or false? Like in that you have asked for the dish type mirror, like because that we made the mistake in that because there is no dish type mirror is there, dish type system is there. So we got confused with the dish type mirror and parabolic mirror because there is no dish type mirror is there. No. So in the question, it is asking the dish type mirror. So actually the dish type system is much more efficient and it is expensive. That is there in the lecture that we heard, but because it was asking in the question the dish type mirror, so there is no dish type mirror is available. So that got confused with that.
Yeah, if there are any confusions, please send an email in the groups there, right? The TAs can help you in that regard. Then the TA and myself also sometimes check. So if there is any confusion in any terminology in the problem, if you send an email, then we will try to reply back as quickly as possible.
We'll do that, sir, next time. I didn't know that. Yeah.
Yes. There is a group list, problem solving list, right, in SWAM. So many of the students are asking questions there. So please check that out. Okay, if there is any confusions, you can send an email there or a post there. And I have 3 TAs who are looking at those posts regularly. And if even if they are confused about something, then they can bring the questions to me and I then clarify it also. Just 1 minute. Okay, let's see how many have joined. So Minal had asked a question regarding the solar PV course material in week 6. Am I correct? Minal, you are here, right?
Yes, yes, sir. Yes, sir.
Yes. So let me just go to that section here. This is the lecture slide you are talking about,
Yeah.
correct?
Yes, sir. Yes, sir.
Yes. So here, one point I would like to note, so for everyone else, he is asking that here the field fraction is given as field fraction at 0 kelvins is 1 for all energy levels lower than the Fermi level. And field fraction is, at 0 kelvins is 0 for all energy levels greater than the Fermi level. But here in this figure, it appears as if the field friction becomes 0 at the top of the valence band, not at the Fermi level. So the clarification here is this is valid for all allowed energy levels. Okay, so there are forbidden gaps, so within which no electrons can exist. So if you look at an allowed energy level, and if the value of that allowed energy level is less than the Fermi level, then its field fraction is 1. And if an allowed energy levels energy value is greater than the Fermi level, then its field fraction is 0 at 0 kelvins. So here in this insulation case, the last allowed energy level before the Fermi level is the top of the valence band. So up to that, the field fraction is 1. Here is forbidden, so there is nothing allowed here. Okay, so here the all not allowed energy levels, you will always have 0. Okay, so those are not taken into consideration. Again, the next allowed energy level is the top of the conduction band. Here the
Yes.
field fraction is 0. So that's the answer to your question.
Okay, thank you, sir.
Okay.
Sir, one question in that,
Yes.
the below the Fermi level means it's it underneath the graph or like it's above?
So if you see this, this is the energy value, okay, going
Yeah.
up. This is the
Yeah.
Fermi level, okay. So any allowed energy levels below this Fermi level will have field fraction of 1 at 0 kelvins, okay. And any energy level that is allowed above the Fermi level, no electrons will be present. These are field fraction will have field fraction will be 0. So remember, in a solid, there are multiple bands, right, of allowed bands where electrons can reside, separated by forbidden energy levels. So even below the valence band, there will be other bands also, and in between there will be forbidden gaps where no electrons can reside. Okay, this is just quantum mechanics, that some regions electrons cannot exist, and in some energy values electrons can exist. So Fermi level gives you that above that level, even in all allowed energy levels also, there will be no electrons at 0 kelvins because there isn't enough energy. So that's the does that clarify?
Yes, sir. Yes, sir. I have a doubt with the Fermi level line. It is written between the two gaps in middle.
Yes.
So I'm thinking that straight horizontal line should be in that line layer.
No.
In between. Yeah.
And what happens is when the temperature rises, then it becomes a continuous curve. So now, of course, so here, if you think of this as the insulator region, here, this dotted line, this is where the valence conduction band starts. So there is some non-zero field fraction here. So some electrons can exist here. And again, here some electrons less than 1 will exist. In between the forbidden gap, even though the field fraction values are giving as non-zero, there is no electrons because it's a forbidden zone.
Okay, thank you, sir.
Yeah. Let's see what the other questions are. So Venkata Nagaraju has asked, about the exam pattern and what type of questions we are expected. So the final exam will have like a short problem type questions like the one you are solving, and a few multiple choice and objective type questions as well. So it will cover the entire syllabus rather than every week, and the pattern of the questions will be very similar. We will have some true false, some like choose the correct answer, some small quantitative questions, some conceptual questions, all objective types only. So the pattern will be very similar, only in the final exam you have to cover the entire syllabus. So that's the thing. But no, it will not be very different from what you are doing in the weekly assignments. So though you can think them as practice type questions, similar types of questions will be asked. Jayaprakash, is Jayaprakash here? Yes. Jayaprakash, you have asked why insolation will be the same at all the latitudes in the northern hemisphere in summer. I will give you the physical reason why that is happening, but we also discussed this in the class. So let me open the correct course material for that. Let's see where it is. So this is solar collector. It's probably here. Yes, so here you can see this figure of daily solar insolation with latitude and seasons. All right. So here you can see this is the northern hemisphere. July, August, September, October, November, December. So if you see, July is the summer. Okay. So this is June, this is July. So these are the summer. And you can see the insolation values are very close to each other for all the latitudes. The 6° north, 48° north, 36° north, 24° north, 0° north. And the reason this happens is there are two aspects to it. Firstly, of course, the solar energy is still inclined. So there will be an inclination, so which decreases the insolation per unit area at the higher latitudes. But also at the higher latitudes during summer, because the earth is inclined, the number of daylight hours continues to increase as you go up towards the North Pole. And eventually when you reach above the Arctic Circle, you get 24 hours of sunlight. So there are two effects that are cancelling each other out. Near the equator, the sun is vertical, but it's still nearly 12 hours of daylight and 12 hours of night. So you are getting more watt per meter square for a given unit of daylight time, but the number of total time available is low. Okay. Whereas in the higher latitudes, especially in the summer seasons, because you are 16, 18 hours of daylight, you have just longer duration of low intensity sunlight, which is why both of these things cancel out and you get the total daily insolation almost the same during summer. Does that answer your question?
Yes, sir. Yes, sir. Now clear.
Okay. Okay, good.
But yeah, now clear, sir. Yeah. Thank you, sir.
So Dev Saran has asked, cannot read the entire thing. How many number of nuclear plants can replace thermal plants in India? What is the feasibility? How to handle the radioactive waste for nuclear plants? So we have not really discussed nuclear power here, primarily because of paucity of time, nothing less, more than that. But you will require a lot of uranium fuel to replace all the thermal power plants. So if you look at the total power requirement in India, so we have that curve. Let me see in the very beginning, right? So here it gives the total primary energy. Electricity will be lower than that, but let's use that figure for now, just a rough estimate. So it is around 900 MTOE of energy that is there required, out of which not all of it is electricity, of course. So maybe 1/3 or something will be electricity. So you can think of this as 200 or 250 MTOE of total prime energy is electrical. So that is a significant amount of electrical energy. So currently nuclear is like 6-7%, maybe less in terms of the total electrical supply. If everything has to be replaced, you will require at least say 20 or 30 times more uranium fuel input than what is happening today, which is currently not feasible. There isn't enough uranium. Maybe there is enough uranium in the world, but the demand supply mismatch will be there. And currently it is difficult to see how you can replace the entire thermal power plants by nuclear entirely. There are certain countries that have this kind of a system. So like France, at least 10 years ago, around 70% of its electrical demand was coming from nuclear. So it can happen, but the amount of uranium or thorium availability is not enough to replace the entire thermal power using nuclear power. But clearly you can significantly increase the amount. But of course, as you pointed out on that point as well, that there is a problem with nuclear waste, and nuclear waste handling is a very controversial area. How to safely handle it, where to keep it, and wherever you want to keep it, the local area people will have objections to it. So currently, like long-term, very long-term nuclear waste storage is still a controversial and environmentally problematic issue. It's not that it cannot be kept for 100, 200 years, but since the radioactivity remains for thousands of years, there has to be a mechanism of safely monitoring it for over many hundreds of years. And very few governments or countries have such a long-term outlook. It's difficult to see how a mechanism can be developed with such long-term outlook. So that is one of the main concerns with nuclear waste handling right now. Any questions regarding that follow-up?
It's clear, sir.
Okay. Okay, so that completes all the questions that have been given in the Excel sheet. So any other questions or comments or suggestions from all of you who are here? I will be here till 6, but those who are here, somebody has said something in the chat. Okay, just thank you. Okay, thank you. Yeah.
Sir, some more numerical problems are required. As per concept is getting clear, but for practice purpose, 1-2 more sessions to be done with your, maybe with your TS, so that some numericals are given importance.
Okay.
Yes, sir.
I will try that maybe. Okay. Let me see, talk to my TAs and see if we can provide a few more numerical problems. Okay. I will talk to my TAs and make maybe a recording or something and upload as a separate numerical session. I will do that.
Sir, one question was in wind section, wind energy section. There was a wind farm. The question was like that, or there are a set of wind turbines, but the of different maybe of different dia of blades, blade length, but the total energy output is independent of the number of diameters of the blades. How it's happened? Question was like that only. Total output is independent upon the number of not blades in a wind turbine.
Which assignment number was this?
Assignment of wind energy is 4, sir. I think it's a 4.
Just let me check.
a question like that. I'm not exactly remembering, but the total power output is independent of wind
Yes,
blade
net
diameter.
power generated
Yes.
by a set of wind turbines in a wind farm is independent of blade diameter. So,
Yes, sir. How it is, sir?
yes, let me just go to the wind turbine lecture.
Yes, sir.
Just 1 second. So this is the last slide of the last PPT. Okay. So if you see here in this wind farm land footprint section, just take a look at this figure. Okay. So this is a, say it's a rectangle, right? So wind turbines are placed at certain distance between, so a minimum distance has to be kept between two wind turbines so that the backside wind turbine does not enter the wake of the front wind turbine. So suppose wind is blowing like this, the wind has to recover its momentum before it hits the second wind turbine. Otherwise, the second wind turbine will not be able to function properly. So you have to keep around 10D or 8D distance between two wind turbines for each of them to work with its proper efficiency values. That much is clear?
Yeah, that part is clear.
Okay. Now, the power delivered by a single wind turbine is proportional to its diameter square. This we discussed earlier, right? However, the wake region is also proportional to diameter. So if the wind turbine diameter is D, then the next wind turbine will be around 10D or 8D after it. Okay. So over a given land area, how many wind turbines you put is actually, the number is inversely proportional to the diameter along the length, and again inversely proportional to the diameter along the width. So suppose this is 100 meters cross 80 meters. Okay. And suppose the diameter is 1 meter. Then if the wind turbine diameter is thinking of very small wind turbines here, then this is at initial, then after 10 meters, another wind turbine can be put, another 10 meters, another wind turbine can be put, and in this way, 10 wind turbines can be put in this side. Okay. Similarly, 10 wind turbines can be put in this way. Okay. So if the diameter increases to 2 meters, then this becomes 20, and only 5 wind turbines can be put here. And again, similarly, around 5 or 4 wind turbines can be put here. Okay. So as the diameter of a wind turbine increases over a given land area, the number of wind turbines you can place will decrease. Okay. And the decrease will be proportional to 1 by D along length and 1 by D along width. So again, the proportionality will be 1 by D square. Okay. So what we discussed here is that power generated by an individual turbine is proportional to D square, but the number of turbines one can place in a given area of land is proportional to 1 by D square. Thus, net power generated by optimally placed turbines in a given area of land is independent of turbine blade area. Okay. And the average value is 4 megawatt per square kilometer of land. It's more or less fixed, depends on the wind velocity, of course, but overall you are getting this as per meter square of land, the amount of energy generated is more or less constant. It does not depend on the diameter. So that is the question that was asked.
2-3 concepts were clubbed, so it was difficult to get.
Yeah, yeah, it was. Yeah,
difficult to judge in just true and false.
True.
If some calculation were there, then probably
no,
I
this was more of a conceptual
more.
thing that in
Yeah.
a wind farm area, what is the power generated? That was like averagely constant. It does not depend on the diameter. That's the.
Yes, sir. Yeah. Nice, sir. Thank you, sir.
Just one
Got
or
clear.
two harder questions just to keep you on your toes. Most of them are easier. So that helps you clarify also these ideas a little bit.
It's good, sir. But some numerical, if numericals
Yes.
are in the form of numerical, then our concept will be more clear then.
Okay. I will
Will be
ask
an
the
application
TAs.
part.
Yes, I will ask the TAs
that
to
will be
give.
an application part.
Yes.
Yeah. Thank you, sir.
And the week 5, the question number 12. That how many times the radiation is falling?
Just 1 second. Week 5, how many times the daily available solar energy per unit area of ground surface at 20° north exceeds that available at 60° north? Is that the question?
Yes, sir.
Okay. So were you able to identify the plot where this was given?
Yeah, we identified the area, but couldn't be able to identify it is 16. That is right.
Just 1 second.
It is the same graph you have shown before.
Correct. I'm just trying to find it again. So this is the month of December. Okay.
Yeah.
12° north is this one. Okay, so between 20 and 25, so this is 22, assume 21 or 22. Okay, so this value at 12° north, this insolation megajoule per meter square per day is around 22 megajoules per meter square per day. Similarly, at 60° north here, this is say 1 or 1.5, something like that. Okay, so if it's 1.5 or something, it will be like 22 by 1.5, around 15 or 16. And if it's 1, then it's 20, 21, 22, right? So obviously, given all the answers, only 16 times is the closest. So everything else is lower than that. So that's how you choose the answer.
Okay, thank you, sir.
Okay, yeah.
Sir,
Yes.
thank you very much for all your lectures. First of all, I am happy with the course progress. Basically, I got so many new ideas. I am thinking solar is expensive. As a professional engineer, I am just neglecting. Solar is expensive. Yeah, mostly I am not recommending also. Yeah, I live in Africa, so I'm not recommending most of them. Solar is still expensive. But now, after seeing the levelized cost of solar, now I am moving in, my intention is almost diverted. Thank you for including cost issue in your lecture. Thank you very much.
Thank you. Take a look at, there are several reports available in the internet from International Energy Agency, or there is IRENA report on renewable energy, annual report on the progress and the costs. So most of the data, like not the quantitative part, but the levelized costs and everything have been taken from the reports and their data. So check those out. And also, of course, in a given country, the cost of solar may differ based on what is the supply chain there is. So that may be also a factor. But globally, solar has decreased significantly in many parts of the world. So clearly, it's becoming more economical to go for solar than other forms of electrical power production. So good to see that this course has helped you in some ways in your engineering practice as well.
Thank you, sir.
Thank you.
Sir, in this question only, sir, how wind is also levelized cost of wind is coming equally to solar? I'm unable to digest this.
How many?
Because how wind energy cost, levelized cost of wind energy is also coming down, because wind power installation is still very costly and it is limited to some area only where wind is mainly European countries and all, where wind velocity is good, offshore wind and all. Cost is installation of wind cost, wind turbines and all, still on higher size. Then how it levelized cost of
so the levelized cost takes into account the entire life cycle. So for example, a wind turbine farm will run for 20-25 years. So this is assuming that you have a space where there is sufficient wind velocity. So like European areas. So of course, if the wind velocity is low, you won't choose that as a place where you want to put wind turbines. Okay. So you need to have a sufficient wind velocity, as we discussed, it's cube of the velocity, right? The power output, to get the kind of power output per meter square that makes it economical. So among those economical sites, if you install the wind turbines and it runs for say 20-25 years, clearly the running costs are significantly lower than costs of say coal or oil or nuclear kind of things, primarily because you are not required to put fuel, do maintenance of your furnaces, turbines, compressors, which need to be changed because of the thermal degradation and all of these. So the levelized cost takes into account how much electricity you are getting over its entire life versus how much cost it is happening, including your installation and its maintenance over its entire life cycle. So then the levelized cost estimate is being done. Of course, wind turbine initially is going to be capital intensive. So if you compare to a gas power plant versus a wind power plant, initial capital cost for a wind power plant will be higher. But over time, as the cost of natural gas is there, for example, versus the wind, the resource is free, and once the machine rotates, there isn't much you need to do. Maybe a little bit of maintenance here and there. Of course, offshore you have more maintenance, so their LCOE is higher. So that way the LCOE comes down.
It will be true for India also, sir?
In some places, because this has to be, again, I have to look into a little bit granular detail of where this LCOE costs will balance out for India. India has lower wind resource compared to say European countries, England, Canada, and other places. But offshore, there are possibilities. In Western India, there are possibilities. Even in the Southern India, there are possibilities. But again, that needs to be like, I have to study more to figure out for that specific site, what are the requirements, what are the wind speeds and what else is there. In India, the another problem, of course, is most of the electricity is subsidized. So it's difficult to figure out what the cost structure is supposed to be. So wind installations are coming up, and I think LCOE in India also in certain places will be lower than coal that is increasingly becoming imported, right? So that is a concern.
Sir?
Yes.
I think feasibility study should be done to identify the potential site.
Correct.
In Europe, we may get in a high latitude, we may get so many places suitable for wind. In equatorial subtropical, we may get in few places, but they may have better performance than the Europeans.
Yes.
Yeah, we are observing in Ethiopia the same things. Small local areas with high potential of winds, and the government is installing wind farms around few localities identified by feasibilities.
Yeah. I mean, certain highland regions in Ethiopia will have good wind resource. I am
yes.
Yeah.
Okay. Concerning tutorial,
yes,
it is better for us to give a problem we try instead of video. If there is a worksheet or tutorial assignment overall, starting from the first chapter up to the end, we can try only with answer. We will check ourselves. If there is only in that case, we will equip ourselves with workout problems. Yeah, existing one is also available, but a tutorial set, we will try up to the end of the chapter. If we get some tutorial, every chapter 4 or 3 questions, we will practice by ourselves, and we will make a self-check with answers. If answer is given, we will check ourselves. We will also browse and study further material if we are not getting the right answer, correct answer. In that sense, it will be
better. Understand. Let me see if I can put some practice problems as a PDF with then a solution key later, so that you can check, and then we will give the solution. So that way I can try something out. I will do that.
Okay, thank you.
Yeah.
Sir?
Yes.
Sir, the feasibility of solar power is higher in South India, right? Because of the more daylight hours.
Correct. I mean, the impact is lower because it's more that South India is more of a highland, so the plateau region, so there is a greater insolation of that. Of course, there is a latitude difference, but it's not that much of a difference. But yes, South India will have greater insolation than North India in general.
Thank you, sir.
Sir?
Yes.
Sir, in assignment 5, question number 13, there you have asked to calculate the solar declination angle.
Correct.
L latitude on 15 September, sir.
Yes.
But we calculated as per the formula given, and for winter minus 23.45 we have taken.
So
and the day number is
so I think you misunderstood the formula. Let me just go to that question. So this is declination is here. So this delta zero value will always be 23.44 degree. What I meant to say was, on the day of summer solstice, this delta will be equal to plus 23.44, and this delta will be equal to minus 23.44 in winter solstice. Okay, the sign will be taken care of by the by this n value. Sign becomes positive and negative, right, cyclically. So you don't have to worry about the plus sign or minus sign here. This delta zero will be 23.44 only. Okay. And you always put that and then put n. N is the number of days of the year. Okay. That's number one. And the second is, even on the 15th September is still in the summer hemisphere. Remember, the fall equinox is 23rd or 22nd September. Okay, so it will be +2 already. Of course, it's not yet in the winter half. Remember,
So delta
summer,
naught minus, so we should not take, sir, at any time.
not any time.
Only
Delta
sign
naught
of the
will be-
angle only.
Sign
But if
will
the
be-
angle is more than 180, it will be negative. That's
yes, correct. Okay. And
Okay.
15 September is still in the summer half. Okay, so that also you need to remember.
Yeah, that is for north side.
Yes.
You said July to December, it will be in summer.
No, in the summer month and summer period is different. So
Okay.
you understand? So 6 months is the winter inclination and 6 months is the summer inclination, right? So
Okay.
that way. Okay, equinox to equinox.
Anyway, based on the n number, the negative or positive
Yes.
will come.
Yes.
But why this delta naught minus plus is mentioned, sir? What is this?
So this should be delta. Delta equals to plus 23.44 in summer solstice. So what I was saying was,
You said delta naught, sir. Delta naught is
yes.
written.
So this here is mistake here. So this will be
Yeah,
delta.
because of that only we got minus 2 degrees, but the answer given plus 2 degrees. That is a confusion, sir.
Yeah, but delta naught will be 23.44 only. Okay.
Yeah. But because of the bottom delta naught, we thought of keeping minus sign. If there is any possibility, please see, sir, that one.
No, that won't be, because it's still in the summer half, right? September 15th. So it's not in the winter side. So
right.
Yeah. So for example, here in this example, February is in the winter half, right? I have put plus 23.44 here and got negative value. So this is how it is to be done. Delta 0 will always be 23.45.
For the winter, it will be negative, right, sir? The delta 0.
No, the delta 0 value will be 23.45 always. You don't have to make it positive or negative. The number of days itself will take into account, because this is sine 311, it becomes negative. Sine has positive and negative values, right? So that will take care of itself, the negative and positive.
Yeah, actually, like even I have done the same way, but I took because of the summer, it is +2. That is how I took the answer.
Yeah, I understood. But if you do it this way, delta 0 as 23.45 and sine, whatever the value of sine is, you keep, then the positive and the negative sign will take care of itself. You don't have to worry about it.
Yeah, the answer came like 2.281, something like that. Then it was a confusion whether it is plus or minus. Then I took it because it is summer, so
Yes,
it is
correct.
plus. That is what I have done.
Okay, that is okay. But from next time forward, you just take this formula and just put it directly. So it should work.
Yeah, in that formula only I have put it directly, 23.45 and 360 multiplied by 284, and n also has given, and it is around sine 534 something is coming, and I took the sine value and multiply by it, it is getting 2.284 281. Yeah, and then the confusion came whether it is plus or minus. With the option, it is.
Yes. You are getting 2.284, then it obviously is plus.
Actually, me, after doing 2.21, by checking that delta naught, again I changed it, sir. Actually, first I got plus 2 degrees. Something I have to take minus, and I changed it.
No. It's
actually, because of that, we are losing 10%, sir. That is the only matters a lot. Because four points are there, na, sir.
Yeah. Okay. Yeah, somehow it came into the correct in my case, like because I have taken summer is positive. So I understood. Now the sign value has to come as negative or positive, right? That is what you are saying.
Yes. Yes.
Suppose if the sign value is coming in the calculation, if something is coming negative and it is coming in the summer, then what we have to, or in the winter,
It
what
will
we
never.
have to take?
In the summer, it will never. So there are two equinoxes, right? So the March equinox and September equinox.
Yes.
Between March and September equinox, delta will always be positive. And then between September to March again, so October, November, December, January, February, March, delta will always be negative. The formula is created such a way that this will automatically happen always.
Okay.
So March equinox to the September equinox. So April, May, June, July, August, up to September, delta will always be positive. And then after September equinox, at September equinox, delta will become 0. And then again, it starts to rise, go down. So October, November, December, January, February, up to it will be negative. So what you can do, it's a good exercise. You put an Excel sheet, right? Put the number of days and change it by say 10. So 1, 10, 20, 30, 40, and find how the delta value is going. And plot it, and you will see it's kind of a sinusoidal curve with plus 23 and minus 23 at each end. And the 0 at the equinoxes.
Okay, thank you, sir.
Sir, some of the slides that you explained while in the class, they are not there in the material, sir.
Is it
in
true?
Problems, especially some example problems and some slides, comparison slide you kept. They are not there in the material.
Tell me
PDF.
where I will have to check.
Shuffled
Maybe it
and
got
it is
shuffled or
there.
something. Can you check once? Which one is it?
I think it may be.
Because this is the repository, then it comes to you from this repository.
Sir, week 3, 176 efficiencies of various collectors we have given comparison.
Okay. Solar collectors, right? Week 3 is hydropower. It won't be week 3, right?
No, sir. Week 5 only, lecture 3.
Yeah. Week 5, lecture 3.
Okay, sir. They are there, just Sheffield, sir.
It's there. It's there, right?
Yes, sir. Yes.
Okay. Yeah, yeah.
I have attended many NPTEL courses, sir, but what I observed is you have given material, but unless we listen to your voice, we cannot answer some of the questions. That is the clever way the questions are prepared, that I observed, sir.
Okay.
Because some questions, they are not there in the material, but keenly if you observe your voice, there the answer comes. So
Okay.
such a way it is prepared. Just by watching PDFs, we cannot answer every question.
Well, that is good.
There are
that I
other
observed,
NPTEL courses are also like that. So it is it's not true. It is fine.
Especially flat plate collectors are not suitable for cold systems. We explained, sir, because that freezing may be done. So nicely you tell before you said that they are better than this, just given a pass. But you see, sir, I observed whether you see it or not. One problem, last problem, sir, 15 problem. I just made a copy and paste in the Google, sir, just for the sake. One person in a blog, he kept answers with explanation. on 27th August. But most of his answers are wrong. So this is the way somebody is maintaining the blog.
Which blog is this?
I don't know, sir. Just last question, if you copy paste, you will get a link. With explanation, he is giving answers, but he don't know the course also. But the answers are quite wrong. Most of the answers, but somebody may be misleaded with that.
I don't know. I have no idea.
Yeah.
So when will be the next section after this, the live section?
I will try to do the end of next month or something like that. So maybe
that will be very close to some October 28th. So how many live section will be there before our exam?
I can do another one maybe in 15-20 days. Will that help? I can do more. Yeah, there is no issues.
No problem. There will be a link of saying ask question in under the video. If that will be good to ask question.
Yes, you can do that. Also, you can ask questions in the forum. That is easier.
That
So,
don't know where it is. I never used it. I'll try to find out. I have seen like the spreadsheet you have.
There is a Google group associated with the course itself.
Okay.
So I have the SWAM. Let me see. Yeah, here. Let me see where it is. Okay, what is ask a question? I see a little bit. Yeah, when you do an ask a question, you go to the Google group. Yeah, this is the one. Okay.
Okay.
That's what I was talking about.
Yeah.
You ask any questions and the TAs will help. And if still there is any problem, I will help you. Okay. I will try to do another live session in 15 days.
That would be. Thank you.
Okay.
I think, sir.
Yes.
At the end of the lecture, almost now halfway, close to the final is better instead of 2 weeks. 2 weeks means after 2 lectures.
I mean, I will have 3.
Okay,
so
okay.
Do 3 sessions. Okay.
Okay,
so
thank you.
the
Thank
final
you.
one more and 15. So yes.
Yeah, we need more also. We need more also.
Yes.
Just I am thinking that will be the last. Instead, it wish to be at the end.
No. Typically, all the participants become more active near the end. So I prefer to have it now and then another 2 in quick succession. So.
Thank you. Okay, you're welcome.
Sir, is there any possible to enable the transcript, sir? That means when you are speaking, the words will be enabled and that we can take it as a
transcripts are there, but it takes time. The process here is we have to do our own transcripts and get it proof corrected and everything. Automatic transcripts are difficult. So
yes, sir. Because at the end of the day, we cannot go through every video. We cannot spend much time. Whatever you have spoken, that we can go through if they are available.
Transcripts do not come immediately, so that's the problem. So the course participants are supposed to watch the videos and then
that's okay, sir. But because some NPTEL in the bottom complete whatever he has spoken, the transcript is available. So whenever we get a doubt, we know we can go through that. Because not now, sir, but end of the day, watching every video is difficult.
Because this is the first time the course is running. The transcripts usually repeat courses will have the transcripts. So that's usually how it works.
Sir, we have finished our coaching from the
Sorry, can you repeat?
How far we have finished our courses and the course.
So which week are you in?
We are in week 6 and
week 6, right? Hello.
Yes, sir. We are in week 6 right now.
So 12 weeks total, is it?
Yeah.
Yeah. So halfway.
Yes, sir.
Yes.
In previous slide here.
Hold on. Yes.
Not here. The one which states thermal resistance is a function of temperature. Modeling aspect.
This one.
No, at the bottom. One. Yeah, here.
Yes.
How we determine alpha 1 and alpha 2? Is that from experiment or from modeling?
Semi-empirical. These are semi-empirical. So as soon as you do yes.
Yeah, okay. So
I mean, there are ways to do it. I mean, if you do a full heat transfer analysis, take resistances and measure it, but it's still like experimentally determined. Like what is the convection heat transfer coefficient? What is the radiation heat transfer coefficient? Add them up.
It fits with this quadratic equation.
We fit it. It won't necessarily.
No.
Yes, but
yeah. Okay.
Yeah.
Okay. Thank you.
Yeah, I haven't gone into too much detail on those things. It's mathematically challenging as it is, right? So, but if you are a heat transfer expert, then these are some of the things you would do, like you do full scale modeling of these things. So we are almost at the end of our 1 hour session. Any final questions from any part?
Sir,
yes.
With the remaining last minute, what will be the next contact, the remaining 6 chapter? I already saw.
Okay. So after solar photovoltaics is done, we will go into biofuels and bioenergy. Then it will we will go into hydrothermal energy systems, geothermal energy systems, and then we will go into energy storage technology for renewable grids. There are different types of energy storage systems will be discussed, and how they can do different types of functions in a renewable grid infrastructure. That will be discussed. So it will discuss batteries, capacitors, and all of those things.
And what about nuclear? Because the way you present, I like it, basically. That's why I wish to have deep knowledge on nuclear also.
So nuclear I have not covered because there isn't enough time. Because after the energy storage, I went to renewable hydrogen, which is also becoming very important. So I have to keep something and remove something, and renewable hydrogen, and then I have to. I also covered carbon capture and storage. So that makes it quite long actually. So so I had to keep out nuclear because of that, just to make it tractable for everybody to finish. Like otherwise, it will be very difficult for everybody. So that's all.
Okay, thank you.
Yeah. Sorry, no nuclear here, unfortunately. In the course overview, I put, I think, the basic what I wanted to cover, right? So the nuclear wasn't there.
Yeah, I remember, sir.
Yes. Okay, session is done. So thank you for. Okay, Dept sir is asking 5.9 million tons of lithium. well, that will make lithium very available for Indian industry. So if they can actually get this lithium extracted, then India will be a major hub of lithium. I have to check what is the current lithium resource. Most of it is currently in China, but there are resources available now in India, in Japan, and other places have been located. So as people look, there will be more lithium storage coming up. So when we discuss our battery technology, we'll discuss the importance of lithium-ion batteries as well, and how they are very important in renewable energy storage systems, as well as, of course, EV vehicles. They are coming. So yes, any lithium resource in India would be a great boost to our economy and our internal energy storage and EV facilities.
Thank you for the detailed answer, sir.
Okay. Okay, so I will stop here today. Let me know if you have any further questions on the ask questions, and TAs and myself will look into it and give you details. Also, if you have any specific requirements on like want some reports or something or specific research topics that you want to work on that is different from the course on sustainable energy, I can give you some pointers as well. So not just problems. If you are specifically looking at, say, some specific technology in energy sustainability, and you want some pointers on research reports or everything, I can give you some links there and you can do your own work there. So if that is something you are interested in, I can help you with that as well. Okay, so I will stop here, and good to see you all, and we will schedule the next tutorial soon. And I will prepare a set of practice problems with our TAs. I will do that also. Okay. All right. All right. Thank you.
Thank you, sir.